Thanks for inviting me and Bram here today. I will talk about the work we've been recently doing on the EPOS Multi-Scale Lab data catalog. Most of you will be familiar, I hope, with that EPOS is a data portal and provides access to solid earth scientific data, among others to multi-scale lab data. And I will briefly go into what EPOS is doing sort of centrally and what we've been doing for the multi-scale laboratory data. I'll mention a few people. Myself, I'm talking. Everyone in the bottom has been very important for the data services, but I'll mention specifically Laurens, who is currently the IT developer of the multi-scale labs catalog, and yourself, because many of you have actually contributed to developing the multi-scale lab vocabularies of various disciplines and in further developing the functionality of the catalog through commenting on it. So zooming out, this is the issue. See if I, can minimize that. Without an EPOS, people publish data, open access. So that's absolutely wonderful, but it's open. But if you actually look for data, if you search for data, you have to go through all these data repositories across Europe to find the data that you need. So if you have to go through all of them, it's a horrible job, and it must be a better way. And there is. EPOS provides central access, makes all these data findable in one place. At least that's the goal. It does so through the EPOS data portal, where all these disciplines within the solid earth sciences are made available. Among others, multi-scale labs. Multi-scale labs, or MSL, has 6 data services corresponding to the various subdomains: analog modeling of geological processes, geochemistry, paleomagnetism, rock physics, microscopy and tomography, and there's a search all function. And then within a specific service, you can search for data. Here, data of one Audrey, or data within analog modeling. Also, people we know very well. Frank Swan is here, Francesca, we all know. So that's absolutely wonderful. MSL can be found here alongside the other disciplines. So if you search for lab data, you can also find geological data that may be relevant for your research, or seismological, or fault occurrence, or whatever. Now, we also have a MSL data catalog. So why would you bother, you think, if you already have the central one? Well, this one, we have control over ourselves, which means that we can develop functionalities that are a bit easier for MSL specific needs. Okay, so we can cater more directly to whatever MSL research needs. It can also be a testing ground for testing multi-scale lab services that can later be added to the EPOS data portal, right? So clicking on data access at the EPOS Multi-Scale Lab data catalog, you find this page. First of all, this is what strikes most: 276 data publications. This has increased 2- or 3-fold over the last 1 or 2 years, so that's a good thing. But it needs to increase more, and we will do that in the coming years, and I will briefly go into how we are going to do that at the end of this presentation. But what I want to talk about now is this left facet, so the filtering tree, that's what we call it. This has been the innovation of the last 1 or 2 years. It is based on the multi-scale lab vocabularies that all of you have helped develop and update. And the way this works is that you can use this filtering tree to filter the data publications available through this catalog. For instance, by searching on material. So opening the materials, you find all earth scientific materials available, essentially. And you can click on a more specific search, like igneous rock, extrusive, and then click on basalt, and then you find 5 data publications, as shown here, that have basalt as a keyword. So 5 research data publications done on basalt. You can also search for the disciplines on the left side: analog modeling, geochemistry, microscopy. So taking paleomagnetism as an example, Bram Vaas will talk after me and he will go into how paleomagnetic data is being reused. You can search more specifically on the measured properties within paleomagnetism, and even more specifically on anisotropy of anisotropic remnant and magnetization, still with me? And you find one data publication at present that has got that as a keyword. So one containing this specific term, right? So I think this can be a very useful feature to actually go through your, to discover the data that you might need for your research. Now, what we do to add all these various keywords is we look at what people have originally assigned as keywords, and then we try to enrich them through various techniques, and I will explain how that works. Looking at this specific data publication, just a random one. This data publication has 3 originally assigned keywords, so that's actually quite limited, right? Geophysics again, actually, and rock mechanics. We have added all these keywords in an automated fashion in the box highlighted in green. How do we do that? We harvest the title. So actually looking at the title, you know that this research has been done on shale, limestone, and sandstone. But in the originally assigned keywords, that has not been shown, which means that if you just put that in the filtering tree that I just showed, that you will not find this data publication when you look for shale or limestone or sandstone. Now, evidently, that's a discrepancy, so we want to add these terms, which we've done. So we harvest the title for matches with the MSL vocabularies. We harvest the abstract for matches with MSL vocabularies. So in the abstract, ultrasonic attenuation is mentioned, which means that these terms can be added. We harvest on the basis of indicator terms. So the abstract mentions uniaxial unconfined compression, which means for 99% certainty that a uniaxial compression apparatus has been used. Meaning, if you use the filtering tree and you filter on the basis of uniaxial compression apparatus, you find this data publication among other data publications that have used this particular apparatus. And not only that, we also add parent terms to the terms here. So uniaxial compression apparatus automatically means compression testing, it means deformation testing, and it means that an apparatus was used. Okay, so if you search on compression testing, you also find this data publication. So through this technique, we harmonize originally assigned keywords to the MSL vocabulary. So everyone used the same terminology in that sense. We've increased the keywords from 3, or actually 2, considering the geophysics was added twice, to 19. So all this adds to greater findability. Now, why does this matter? It's more efficient, right? If you reuse data, then you could possibly not have to reinvent the wheel, which is good. We make data much easier to find. If it's easier to find, then the people who have published data get greater impact from doing so. This promotes multidisciplinarity, especially through the EPOS Central Data Portal. And you can also use this search functionality to actually discover people who have done similar research as what you have done. So if you want to make your data findable in EPOS, you can publish here, for instance. These repositories on the left side are currently made available through EPOS Multi-Scale Labs. And in the near future, we will add the ones on the right side. But it will not be limited to that. What we're ultimately going to do is actually harvest or do a search query in DataCite using our vocabularies. That can lead to identification of what data is relevant for multi-scale labs. then we know which data publications to actually harvest, and then we can do so at the various repositories within our network. Okay, so all the data that are being published at these repositories are actually findable in DataCite. So we can use DataCite for automated identification of MSL relevant research. And we can use that to make these available through the MSL data catalog. So in the coming year, we do exactly that. Automated identification through DataCite. We will improve visualizations on how we enrich MSL keywords. We will update the metadata editor at GFZ. So this GFZ is obviously the one that's most known to most of you, I think, at the moment. Conform the latest vocabulary updates. It's currently in progress with Simone Frenzel and Kirsten Elger. We will finalize the adapt metadata selector to let you know this is something that we're developing at Utrecht. It's a tool that can help you select MSL relevant keywords, export that in a list, and you can take that list to your own repository to know which MSL keywords you can add to your data publication to make them maximum findable through the MSL data catalog. So if you use these keywords, it's much easier for us to find your data publication and also to make these findable in our metadata filtering tree. So that's in the near future. In the coming 2-3 years, we will try to move more towards interoperable multi-scale lab data. So most previous work is focused on making MSL data findable and accessible, but now we want to move towards the other letters in FAIR, so interoperability. We will do so by a collaboration we've got with the American Strabo Micro Group. They've got a wonderful infrastructure actually for metadata assignment to microscopy images. And they also have a web viewer to show all this metadata and the images. And by collaboration with them, we hope to also make these available through the MSL data catalog, meaning that if data is being published, image data is being published in the MSL network, we can also make these explorable in the MSL data catalog through this web viewer. And in the coming years, we will also hire someone to work on interoperability within rock physics and analog modeling to see, okay, can we actually identify low-hanging fruit in several of the properties that are available in data publications, but are not highlighted as such, like simple properties like a friction coefficient, Young's modulus, and make these available through a table so people can easily look up what several of these features are. With that, I'd like to close. If there are any questions, I'm happy to take them. Thank you very much.